All right. So yesterday we started to talk about solving a triangle, meaning you have to solve for all sides and all angles. Okay? And I might change my strategy a little bit today. Maybe the first thing that you should do is, because when you're given one angle, you know that this one is 90. You can easily find angle S right away. So I'm going to do that. S is equal to 180 minus the 90, which is this one, right? Minus the 63. So angle S is basically 90 minus 63. So that is 27, right? I'm just going to make sure I'm on live television here. I don't want to mess up. So that's 27 degrees. You already found the one angle that still was unknown to us up until this point. Okay, so there it is. Next, we're going to try to solve one of the sides. This is where my approach is going to change a little bit. Pick a side you want to solve for first. I'm not telling you which one, so you pick. Okay, so you close your eyes and you go 1, 2, right? Eeny, miny, mo, whatever you want to do. You pick a side. Let's say you pick this side, right? Now label. What do you mean labeling, Mr. Dirksen? Well, if this is the angle that you're given, then you travel across. This is the opposite side. Across from the 90 is the hypotenuse. This must be the adjacent. And then we proceed just like we did before. We find the don't know, don't care side. Which one is my don't know, don't care side in this particular case? It's this one, because I decided I wanted to find that one, so I care about it. I know this one. So I'm going to say, hey, this is my don't know. Don't know, don't care. How's that? I don't even know what that, if that means something else. Nowadays, you never know. That's my don't know, don't care side. So what are you left with? Always remember, so, ka, toa, right? Write it down. Some of you need that reminder, right? So I'm left with opposite and hypotenuse. That means that I have to use sine. So sine of 63 degrees is equal to, what's the opposite side? Because that comes first. In this case, it's actually a number. And the hypotenuse is a letter. You put the 1 underneath. You know you're going to start your journey where the variable is. Since the number is up top, you go down and then up. So you're going to multiply and divide. Always multiply, then divide. So that's 3.9. That's what you do. You say, hey, 3.9 times 1 divided by sine of 63. Now you know that it's 3.9 divided by sine of 63, basically. Let me just adjust my camera here. So x is equal to, and we have 4.38 kilometers. Now we've solved one of the sides. We've solved for the hypotenuse. Right, this is the hypotenuse. But Mr. Durson, couldn't I have picked this side over here? Yes. And then this would have been your don't know, don't care side. Then you would have had opposite and adjacent involved. You would have had to use tangent. And that's fine. You'll notice that you'll get the same answer overall. At the end of the day, you get the same answer. So, okay, let's recap. We found the angle. We found that other side here, this one. Now we're going to find this one here. And so maybe let's call this side y. You could call it lowercase s as well. But y is a leg, right? So we're going to have to go hypotenuse, which is 4.38 squared minus 3.9 squared, which is the other leg here. And let's see what that is. That's 3.9744. Take the square root of that. 1.99 kilometers. So step number 1, I found that missing angle because that's easy. You get 1 mark right away. Step number 2, I used trigonometry, SOHCAHTOA, because I couldn't use Pythagorean theorem yet to give me this. Then I used Pythagorean theorem to do that. So basically find angle, use trig, then Pythagoras. That's how you do a solving triangle situation. Okay? All right. So I'm going to slowly transition here. Review. Or build your skills, whatever you want to call this. Number 1, if you're given this triangle here, and let's call this triangle fun, okay? Because triangles are fun, let's face it. And we'll put down numbers such as 2, 4, 7. And I'm not putting units down. Okay? Sine, if I asked you for sine of n, which 2 numbers would you put here? Because this is the one that I'm looking at the AC I just gave, and it gives me immediate feedback, right? It can tell right away overall what's been happening, right, in your brains. And don't feel too bad. You're gonna get the marks back, and some of you are not gonna have done so well. Don't let that beat you up. We're gonna do this again and again and again until you get better at it. That's what your focus is right now. So sine of n is supposed to have 2 numbers going here. N is what you're focusing on first. Where is n? That's the reference angle, right? So you're over here, right, where the n is. Remember, this is always there in the background. This is going to help you place the numbers in the right order. It's sine, right? So that's there. We're referencing from n, so this is where we're standing. Based on that, this is opposite right here. So that's the 2 there. And hypotenuse is 7, so you got to put 2 over 7 like that. Okay? So sine of n would be 2 over 7. What if I told you to find sine of f? What if I said, hey, sine of f now? Let's change it up. Okay? And some of you need to watch the videos again, right? Like if I don't assign homework, just watch it again. Here's f. We're talking sine still, so we're looking opposite over hypotenuse. Those are the 2 numbers that go here. But you can't just grab any 2 numbers, right? So you got to label. F is over here. In this case, opposite would be 4. And hypotenuse doesn't change on this triangle. It's still always 7. But notice how, depending on which angle you're looking at, the top numbers will change. Let's find cosine of n. And then cosine of f. Two numbers, two numbers. It's cosine, so you're looking at ka. So you need adjacent over hypotenuse. You know that the hypotenuse in this triangle is 7. So for both of them, 7 is going to be down here. Okay? That's a fact. Now you need to worry about the top numbers. You should have a pretty good feeling that it's going to be different. So let's go. N is over here. Which one is the adjacent side? Well, you know across is opposite. That is your hypotenuse. So it must be 4. That must be the adjacent in this case, right? So you put the 4 there. Because it asks for adjacent hypotenuse. Cosine of f. F is over here on this corner. We're still talking cosine, so you want adjacent over hypotenuse. So you kind of in your head, in your brain, you just say, okay, this is opposite, this is hypotenuse, this is the adjacent. So that is the number that needs to come here. It's given to me by this. This is like your formula here, okay, to know which numbers to put where. Tangent of f, tangent of n. So I'm purposely switching it up on you. Okay, switching it up so you don't get too used to one way or the other. Now, first of all, tan, we're looking at TOA, which means that we need to have, and if you need to do that for yourself, you know that the top is opposite, the bottom is adjacent, right? You kind of just make a note for yourself like that. Those are the two numbers. Both of them, that is true. Okay. Now we're gonna go get them. F is over here. Across is opposite, right? That's what I need on top, so I'm going to put 4 down. The adjacent, opposite, hypotenuse, adjacent. Adjacent is 2 here under these circumstances. Okay. Tangent of n, it's still opposite over adjacent, I know that, but n now tells me that I'm here. And then going across, that is your opposite, so you're going to put 2. This is still the hypotenuse. Now this is the adjacent, so it's 2 over 4. Like that. Does that make sense, guys? Yeah? Okay, let's do another one. You need to practice this, okay? So write down this triangle right here. Copy this one. It's going to be time for you to try this one. So how about SAD? Triangle SAD, okay? And I'm just making these numbers up. 3, 6, 10. I want you to write down sine of A, sine of S, cosine of A, cosine of S, tan of S, tan of A. They all have two numbers that go in the certain place. And remember, so, ka, TOA every time. So fill in these two with the numbers. Don't be afraid. It's very easy to fix, actually. So go ahead and fill those in, and then we'll continue, okay? Copy it first and then do it. To keep recording for my viewers. My views are just sky high, guys. No, not really. Okay, sine of A, right? So first of all, you basically read it from left to right. Sine, that means that we're with this guy. And we know it's opposite over hypotenuse. But you first need to go and travel over to your triangle and position yourself on that angle. And then label. Like, I don't want you to write it in there because otherwise it's going to be full of labels and it will confuse you, right? Just grab the number. Opposite is 3. Hypotenuse is 10. Okay? Got it? This, by the way, can be 0.3, right? You could write that 3 divided by 10 is 0.3. Some textbooks will do that. I just leave it as a fraction. Later on, we might divide it and get it into a decimal, okay? Sine of S, we're sine again. That means we're using this guy. That means we need opposite over hypotenuse. Let's go and do that. We're at S, so you position yourself here. And opposite is 6. Hypotenuse is still 10. The hypotenuse doesn't change on a triangle. It's the opposite and adjacent that flip based on where you're standing, okay? Because imagine you're standing here and your friend is standing here. It's like, hey, go to the side opposite to you. And you say, hey, yeah, 6 is opposite to me. Your other friend says, no, 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 3 is opposite to me, right? So it's perspective, is where you're standing. So cosine of A, cosine tells us we're using this guy right here. That means we need adjacent hypotenuse. So A is over here. And you kind of have to do the opposite hypotenuse. This must be the adjacent. So we'll put 6 here, and we know the hypotenuse is 10. And you kind of you can almost play this game. If cosine of A is 6 over 10, then cosine of S will be 3 over 10. Like you can almost be guaranteed because S is over here, opposite, hypotenuse, adjacent. So it'll be 3 over 10. Okay? All right, S, tan of S. So tan, that means you're going to need TOA. That means you need opposite and adjacent here in that order. S, you're here. Sorry, I'm blocking the whole page there. S, you're here, so it's opposite over adjacent because we know this is the hypotenuse. Opposite over adjacent. If you're over here, which is the next ratio we're after, these are trig ratios, right? Like you're putting the two numbers that go with that trig function. A is 3 over 6 because it's opposite over adjacent. So it's 3 over 6. So close to getting them all right? Okay. So you're getting closer. All right. So you can be guaranteed that I'm going to ask this over and over again until it sinks in, right? Until you get it right 90% of the time. Let's say you get it wrong 1 in 10. I can live with that, but you should be able to get that right 90% of the time, okay? So expect me to do more of those. How we do. Okay, so let's correct this. This is on page 294 on chapter 7, that booklet that you have. If not, just write it down quickly. So calculate the values of x and y. So we're switching gears a little bit. Two right triangles stacked. You should recognize this. Which one do you start with? This triangle right here has two unknowns. You don't want to work with that, so you want to work with this first. Don't assume that you're always going to work with the bottom one first. It depends on which one has more information, right? So this one is your first triangle and this is our second triangle. And we always worry about right triangles. We can't do the other ones, right? If you see another one. So with this one, x, here is my hypotenuse. So on the first triangle, I'm going to say x is going to be equal to square root of 4.2 squared plus 6.8 squared, right? Because this is the hypotenuse, so you've got to add the squares. And that is 6388. Do not round here, okay? Take the square root of that. That's 7.99. I allow you to round to 2 decimals. That's fine at the end here. But don't round to 2 decimals inside the root. You use at least 4, if not all of them. And then in question 2 here, this second triangle, we're missing the one of the legs here. So we would say, hey, y is equal to square root of the hypotenuse squared minus this leg that you just found. And that is 44.3199. And this is 6.66. And we are in centimeters. So there you have it. Two-step Pythagorean theorem. Why couldn't you use trig right now? Because we didn't have an angle, right? And that's just how it is. Let's do the word problem below it. Let me know if it's going too fast for you, right? If you're missing a step. Here's your word problems, okay? I am actually quite, how should you say this? I'm quite adamant about being able to do word problems, okay? If we don't learn to solve word problems, everything we do or a lot of the stuff we do is kind of pointless because most of these skills are used in real life and trades, right? So if you don't know how to apply it, it's kind of pointless. Okay, so a 40-foot ladder reaches 38 feet up the side of a house. How far from the base of the house is the foot of the ladder? That's a lot of words there, right? Oh, somebody said something. 1 second, it's a little slow here. Okay, then I'll let you go. The 40-foot ladder is leaning against the house, right? So you kind of have to imagine, you have to first of all see that it's going to be a right triangle. If this is the house here, this is the base of the 38 this is the actual ladder here, which is 40 feet long, we're told. It's reaches 38 feet up the house. So sometimes when you know the two sides, then obviously the third side is the unknown. Or sometimes you know which one is the unknown. It makes it easier to put the other two numbers where they belong. So they want to know how far is the base of the base of the house from the foot of the ladder, right? This is the foot of the ladder. This is the base of the house. They're asking for it. It is a leg, so it's 40 squared minus 38 squared. So the hardest part here perhaps is coming up with a diagram. And that's 12.49 feet. All right, that's it. See you tomorrow. Remember the review, and it's open book.